Hi there, and welcome to section 6.3. Today we're going to take a look at more solving of algebra problems. Okay, so last time we looked at, we kind of came up with 3 rules that we were going to use to help us keep track of what we need to do when solving these problems. The first step is to write down the problem as an equation. Our next step is to use our new best friend SAMDEB to do what we call isolate the variable, which basically just means to move everything away from the same side as the variable so that it's all by itself. And the last step that we're going to do is we're going to verify your answer by substituting your answer back into the original equation. So substituting just means to put the number back in, or to put the answer back into the equation. Okay. So we're going to take a look at a couple of examples of slightly different situations here. The first one, we've got a college student paying back a student loan. At the end of the first year, he paid a total of $400, and the balance of his student loan was minus $1,200. How much did they owe at the beginning of the year? And of course, we're going to make the assumption here that there was no interest, which is a very wonderful assumption in a very special world. So our college student, we're looking for how much did they owe at the beginning of the year. So I'm going to call that X, which is the amount of money owing. So at the beginning of the year, they owed X dollars. During that time, they paid back 400, so plus 400. And that is where they ended up, which is at the end of the year, where they ended up still owing minus 1,200. Now the reason this example is a little bit different, we haven't seen this yet, is you'll notice right here we've got a little negative sign in front of one of our variable, or one of our numbers, which is fine. We're still going to use the exact same rules we learned before, follow our SAMDEB, and just remember the lessons we learned on integers when adding or subtracting or multiplying or dividing negative numbers. So we want to isolate the variable. That means we want to get rid of this plus 400 on this side. So I'm going to subtract 400 from both sides of the equation. When I subtract 400, that means this cancels out with that 400 right there. And I'm left with X is equal to, and I have to solve this right here. So I have negative 1,200 minus 400. Which is actually going to end up being, let's see, negative 1,600. And that's my final answer. Now remember when subtracting negative numbers, that we just want to continue to make the number more negative. So we can visualize this example here perhaps with a number line. So if you imagine that on our number line there is my 0 mark, then counting down along here, somewhere over here, I end up at negative $1,200. If I want to subtract $400 from that, I need to continue more in the negative direction. So that would look like something like this. Here's minus $400, which will bring me to my final answer of minus 1,600. Another way to think about this is to just look back at the original question, and it does make sense that at the beginning of the year, the student owed more on their student loan. It's a bigger negative number, so we can be pretty confident that this is our correct answer. Okay, so just because you get negative signs in your problems doesn't mean that there's necessarily something going wrong. Okay, we're going to go back and just do our last step, which is to verify. So I'm just going to try putting this number here, this negative 1,600. I'm just going to go back into my original equation and check and see that that makes sense. So that would look something like this. I would have negative 1,600 plus 400 equals negative 1,200. And when I looked through this, yes, the math works out, so that has been verified. All right, the second example here that we're going to take a look at. Mr. Trask has finished marking exams, and so of course he rewards himself by going to buy a piece of pie with his $20. The pie is cut into 6 pieces. After buying one piece, he has $16 left over. So how much would it have cost him to just go ahead and buy the entire pie? All right. So again, first step we want to do is we want to kind of think about what is our variable going to be in this equation. So our last question, how much would it have cost him to buy an entire pie? I'm going to make that my variable, and I'm going to call that P for pie. Okay, so there's a couple different ways to set up this equation. One way to look at it is to say, well, if I bought 1/6 of a pie, and I had $16 left over, then 1/6 times P plus the $16 that I had left over must be equal to the $20 that I started with. Okay, so taking a look at our steps here, thinking about our SAMDEB rule, I've got this 1/6 here that I don't really like too much, and I've got this 16 that I want to move, but the first thing that's going to move is the 16. So I'm going to subtract 16 from both sides, and I'm going to move down one step here. This 16 cancels out. I'm left with 1/6 times P is equal to 20 minus 16 is 4. And here's where I'm in a situation that's a little bit different. I haven't really seen this before. I don't know how to kind of get rid of this fraction. It's a little bit odd. If you think about what 1/6 means, or 1/6 P stands for, it just means if you take that entire pie, you cut it into 6 pieces. And 1/6 of that pie ended up costing $4. Well, 1/6 P is just the same thing as P divided by 6. So one way for me to get rid of 1/6 P is to just multiply both sides of the equation by 6. So 6 times 1/6 is going to cancel out, and I'm left with P is equal to 4 times 6, which is 24, or in this case, $24. So just looking at this answer here, this looks like a reasonable result, but we're going to verify it. So go back into the original equation. I've got 1/6 of 24, so that's 24 divided by 6 plus 16 equal to 20. And I'm just going to follow this down a step here. 24 divided by 6, that's 4 plus 16 equal to 20, and that is correct. So it looks like I've got my answer. All right, that's it for today.